Hey guys, it is about 70 degrees, sunny, gorgeous out. I just got back from DC, which was not this weather. So I'm gonna go to the beach. I got an update for you guys. I just got my artificial intelligence paper published. Artificial intelligence in the command and control of Airpower. So I thought I'd save you guys the read and just give you a quick synopsis of it on YouTube here. So the whole point of the paper is the nature of war remains the same. One of the defining characteristics of it is that the nature never changes. It's a duel on a larger scale, but the character continues to evolve so that we are in that constant duel where we're seeking asymmetric advantage against our opponent. So with that next asymmetric advantage, how I cleanly see that is the ability to control that fight in time and information. So how do we create multiple dilemmas across multiple domains that paralyzes our adversary while we prevent them from doing the same to us? So that was the ultimate question of how we do that. And just simply with the advancement of the compute, the storage, the amount of data that's collected constantly, that asymmetric advantage is AI. There's no way to control that fight in time in the future without that artificial intelligence, that intelligent augmentation, and then that human-machine teaming of making those humans more capable to fight and to win in that environment. So we must increase our agility across all of the domains while improving our decision making. And AI does that. AI gives us that. We've seen that in the corporate world and just taking companies by storm, putting a lot of companies out of business. So how do we do that in the military? Well, we seek out areas that have massive amounts of data. Where do we have both structured and unstructured data that we can tap into so that we can try to determine correlations and patterns in that data? That's exactly what AI does. AI, some people might think as a human-like thinking mind. That's not the case at all. At the very basic level, all it does is it ties correlations and patterns. And there is different types of AI, but that's basically how you can distill it. Getting that structured and unstructured data all together is going to be a huge problem in the military due to all of our stovepipes, our way that we compartmentalize things, the security levels, etc., but it's doable. And then the very best thing that AI does is it helps with the scale and scope that's just superhuman that we're not able to do anything with. So if you want to think about the Netflix and Amazon recommender systems, there's absolutely no way a human would be able to do that. Well, think about that and then carry that over to some of our joint targeting cycles, our air tasking orders, things of that nature that have huge scale that we're significantly limiting ourselves to a 72-hour window, for instance. Hold on one second. All right, so now that we've determined where our use case is, that is step number one of IDing the use case, the use area. It doesn't have to be a very specific case, but having a problem set is very important because you don't want to just apply AI, just apply AI. That's where you can get in trouble by just trying to chase a buzzword. Next, you're going to need to collect and permission and then store all that data somewhere. It doesn't have to all be in the same place, but you have to have the ability to clean that data and see what data you don't have, potentially go collect that again. That's called cleaning the data. The cleaning the data is usually 80-85% of the work, especially when you're starting off. You don't even know what data you're going to need, much less have it necessarily. So it's an iterative process and it gets improved over time. And you can see improvements in your algorithms as you progress through that process. Then once you get that data, you can start playing with algorithms. There are some general rules of thumb about what algorithms are good for what. If you want to think about correlations, structured, unstructured, big data, very niche data, etc. There's some rules of thumb about how to apply what algorithms there. Once you decide on an algorithm, you're going to plug that algorithm in with the data and start feeding that data through and training that system. You're training the models of those algorithms so that you can actually use them to test and see if you've got it right. And then once you've got it to a good level, then you can start applying that on the real world data that you're getting new. And the thing about algorithms and AI is you shouldn't, in mostly all cases, not determine, hey, this is my algorithm, it's fixed, I'm not going to change it. These algorithms, these models should be continually adjusted over time so that they get better, to iteratively improve on the new data that's coming in. That's really important. Once you train them, testing and evaluation is huge, so that you can tell that you have a system that's robust, it's going to perform as you expect it to perform, to whatever kind of certainty you need. Some systems, 60% performance could be much better than a human, but if you're talking about critical and life situations, you're going to want 99.999 March of the Nines style of confidence and performance levels. So in the implementation, this is where we've just done our best job of training the systems, but now we need to implement it. There's a couple things I want you guys to take away here. Transparency and control are absolutely required. If there's no transparency, if you don't know what the system is doing, you don't necessarily need to know exactly ones and zeros what it's doing. But if you're not able to tell generally how it's making the decisions it is, there's no way that you're going to trust that system. If it's literally that black box, which you're not even under the framing of what the inputs are, you're not going to trust that system, period. And then if it's doing something and you're not able to control it, if you're not able to step in and say, no, don't do that, and adjust, you're not going to trust that system either, and that's going to be put on the shelf or thrown in the trash. Human-machine teaming is absolutely critical here. We're not designing these systems to just go out and solve everything that's wrong with the world and make us better all by itself. Autonomy is a thing, but where we've seen great advantage is in human-machine teaming and seeking that AI met with that human, and then making sure those decisions and actions are infinitely, or at least a couple orders of magnitude better. And we had talked about robust training and evaluation, but that's especially important when you're looking at the potential for loss of life, strategic consequences, high-risk scenarios, an adversary that's intent on screwing with your information or data poisoning. If they're intent on injecting into your systems some bad data to get you to make the decisions that they want you to make, you need to be extra cautious as to the robustness of your system. The way to move forward with AI once you're implementing it, so we're already starting to implement it, is that we're going to seek small victories, either in one niche and be really good at that niche, or we can start in that niche and then branch out either horizontally or vertically to adjacent areas so that we can get robust performance and a larger return on investment or return on value from those. So you might not necessarily be getting money back from this, but you're going to be achieving value. If you're implementing AI to not save more lives or be more accurate or save money, why are you implementing AI? You have to have some sort of value proposition for it. And then throughout this implementation process, you're going to see barriers everywhere. You're not going to have the data. The data is going to be too dirty. You're going to be missing data. The algorithms aren't going to be performing in this one niche area. The key is to just recognize those and then try to knock those down, try to eliminate those stovepipes, create those data lakes, not just for the application that you're going to be implementing right now, but for future applications as well. Don't just solve this one problem at the detriment of creating another stovepipe. Create standards, interoperability, pave the way for that information, that intelligentization of the future. You guys hear the cannon fire in the background on this glorious Saturday. It's Gasparilla here in Florida. Beautiful, sunny, probably 75 degrees. appreciate you guys sticking around. If you guys like this video, definitely hit the thumbs up, like it, subscribe if you're not before down below, so you can get more cool content like this if you guys enjoy it. And then I would love some comments. Most of you guys just watch the videos, don't leave any comments. I don't know how I can improve these for you. So please leave some comments before about what I'm not doing well, what I'm doing well, and then what kind of content you guys want to see in the future. I appreciate it. Thank you.